7th graders. This is Mrs. Trombley with lesson 9.2 on theoretical probability. We're on pages 392 and 393 in your book, if you're following along from your book. You're probably just watching the computer, which is totally fine. Alright, so when all the possible outcomes are equally likely to happen, this is theoretical probability. Okay, so the odds aren't in anyone's favor, equal chances. Alright, so the ratio when there is theoretical probability, the number of favorable outcomes is in the numerator spot, and it's that compared to the total possible outcomes that there are. One thing you should also know is the probability of an event is written P of the event. And no, I didn't make that up. I know I like to tell lots of jokes and use the variable P, but this is true. That's how they do it. So the P of an event, the probability of an event, theoretically speaking, is the number of favorable outcomes divided by the number of possible outcomes. That's a comparison. So, example 1, finding a theoretical probability. You randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? So we have explore here. That's the one the book had. And theoretically speaking means that the chances of me drawing any one of these letters are no better than any one or the other. They all have an equal chance of getting picked. So the vowels in this, we have an E, an O, and an E. There are 3 vowels, and that's what I'm looking to get. So the probability of a vowel, I'm going to take the number of favorable outcomes, meaning the number of times I can actually get to happen what I want to happen, and that's vowels. That would be 3. And the total outcomes here, there are 1, 2, 3, 4, 5, 6, 7 letters there. So here we have the favorable outcomes. I didn't spell that right? There we go. Over, I teach math.
She's not an ELA teacher. She is certified.
I knew it looked wrong. Now that dot's there, I can't erase it. It's all right. So that's it, right there, 3 to 7. Some people might ask you, well, what percent is that? The same way you would figure out a quiz grade, that's how you figure out the percent of this. You just take the numerator divided by the denominator, favorable outcomes divided by possible, multiply that by 100, and we end up getting about 43%. You'll be asked to express them in both ways, so there's the fraction, there's the percentage. All right, using a theoretical probability. So now you know how to find one, now we need to know how to use it. The theoretical probability that you randomly choose a green marble from a bag is 3/8. There are 40 marbles in the bag. How many are green? So there's a comparison here. Maybe some of you are thinking, this kind of sounds familiar. You're actually going to set up a proportion. So you probably are loving it because you're really good at proportions. Mrs. Sullivan and I have talked about how great you are at those. So this will be a piece of cake. Don't eat it though. All right, so 3/8. That's your chances of choosing a green. It says there are 40 marbles in the bag. That's total marbles, nothing to do with green. This 3 is the green, this 8 is the total. So we're going to say 40 goes on the bottom. It needs to go on the bottom across from total outcomes. We want to know how many are green, so we don't know. We'll pick X. Us mathematicians are obsessed with our X's. It's true. All right, so let's solve for X. We're going to cross multiply to make a 1-step. 8 times X is 8X. 3 times 40 is 120. And yes, X is being multiplied by 8. To undo that, we're going to divide each side by 8. And X is equal to 15. So there will be 15 green marbles in the bag. All right, some of you maybe said, well, 8 times 5 is 40 and 3 times 5 is 15, and didn't do all of that. That's awesome. Congratulations. You know your math facts. All right, here we go. An experiment is fair if all the possible outcomes are equally likely. So fair means equal here. So when we look at each of these spinners, one of them is fair and one of them is not. Can you guess which one? I'm hoping that you think this one is fair, not just because I guessed and I got it right, but because each one of these is taking up the same amount of space. There are 2 1s, there are 2 2s, so you have an equal chance of landing on a 1 or on a 2. So I would say fair, because the event is equally likely. When you look at this spinner, odds are that you're probably going to spin a 1 that takes up the greatest space, and then probably 2 next, that's a little bit more, and 3 isn't quite as much. So this really is unfair or not fair. Is unfair a word,
Unfair
Mrs.
is a
Sullivan?
word.
All right.
It is.
So unfair, because they are not equally likely. The space on the spinner is not the same.
It's a lot of adverbs there.
Really is.
Yeah.
You're getting a language arts lesson too. Look at us, cross-curricular. Woohoo! All right. Example number 3, making a prediction. That's really what probability is all about. When you take your AP stats class in high school, you'll be like, wow, I remember those videos. Let's look them up again. How do you make a prediction? I'm sure you'll remember us, right? All right, so you and your friend play a game. The rules are as follows. And feel free to make your own spinner and play this game. It looks like loads of fun. You get 1 point when the spinner lands on blue or green. So when you look at this, we have blue, red, green, blue, red, green. So you get the point if you land on blue or green. Your friend gets 1 point when the spinner lands on red. The first person to get 10 points wins. All right, so letter A says, is the spinner fair? So when you look at the spinner, first of all, these pieces are all the same size. And I see that we have 2 blues, we have 2 reds, we have 2 greens. That means that, yes, the spinner itself is fair because all of those colors are equally likely to spin. So equally likely. Is the game fair? Now, just because the spinner is fair doesn't mean the game is fair. So you get a point when the spinner lands on blue or on green, right? So in looking at this, theoretically speaking, we want to figure out your chances of winning here. So if you land on a blue, 1, 2, or a green, another 2, out of 6, you can win. That means 4 favorable outcomes out of 6 are for you. Simplified, that would be 2/3. So you have a 2/3 chance of winning. Your friend, it says that your friend gets 1 point if the spinner lands on the red. Red can happen 2 times out of 6, which is only 1/3. So the game is not fair because your chances of winning are better than the other person's.
No, my bad.
All right. Now it says predict the number of turns it will take you to win. Now this isn't where I just want you to guess. You actually have to use some math here. We're going to use an equation. Just jot your equation down. What do you think? What do you think would do it? No, I don't know. Let's work on it together. This kind of threw me through a loop at first too. Not really, I'm a math teacher, but hey. Okay, so your chances of winning are 2/3, right? What we're going to do is we're going to take 2/3, my chances of winning, times the number of turns it will take, and that's equal to, do you remember how many points you need to win? It says you need 10 points to win. My vent is making a loud noise in the back. You can hear that. I'm sorry. I will try to speak loudly. It's not me. So 2/3 x, 2/3 are my chances of winning. X is the number of turns it will take, and I need 10 points in order to win. Okay, so now we have to figure out what x is. Maybe some of you remember the multiplicative inverse. All you need to do to get rid of 2/3 is multiply it by its reciprocal. So the reciprocal of 2/3 is 3/2. I'm going to multiply this by 3/2 as well, because whatever you do to one side, you have to do the other. So 3/2 times 2/3 is 1, and 1x is x. 10 times 3/2. 10 times 3 is 30. 1 times 2 is 2, and 30/2 equals 15. So after about 15 turns, you should win. So make yourself a spinner. Try to find yourself someone who will play, and see if it takes 15. I'm telling you, loads of fun. We will see you tomorrow.